third area that was brought up a couple of times, and I mentioned, I'll get back to that, is we mentioned before problems around, I think it was pricing and discounts. I think you asked me about it. And I said, oh, there's going to be some kind of engine thing to handle that. And Chris, you asked me about risk. And fraud is another type of example. There's a number of domains where the calculation of a risk score, of a fraud score, of what should the price be, involves a very large number of factors. So for example, in setting the price, we might say, well, it's based on the dates. Is this the high season? Is this the low season? It might be influenced by the number of people that are going to make a reservation. It might be influenced by, is this a loyal customer? What's the information based on their history? There can be any number of factors that are coming from that we allocated them to belong to different services. And now we're saying, well, how can we do a calculation across all of these things without breaking service boundaries? Fraud and risk are also the same type of thing. We're saying if somebody's making a purchase and we see that they set a shipping address that is very different from all of the other previous addresses that they've shipped to, then maybe somebody has hacked their account and we should flag that as a possible fraud. So now we need to take into account addresses and order totals and the IP address. Where in the world is this request coming from? So we look at this and say, well, crap, we had all of these beautiful service boundaries and all of the data was sitting nicely in its place. And then we got this requirement to do risk or fraud scores or pricing that needs to take into account everything. So how do we handle that? There's a pattern called the engine pattern where IT ops is very much involved in that. The integration scenario that we talked about before is kind of a very simple example of the engine pattern. One of these days I'm actually going to put a slide on the engine pattern. Right? So the idea of the engine pattern is that there is some kind of semi-generic engine. Think of it as a kind of multi-stage pipeline. Where oftentimes there will be services that own a certain step in the pipeline. And in some cases, you can think of it as the services that are kind of plugging into that engine from the outside. All right, so it depends very much on the domain. But let's take pricing, for example. So we'll say, well, what is the price? What is the rate of the room for a given set of dates? So there can be, for example, a base price that gets fed into the pricing engine. So you might see that in some hotels, that on the inside of the hotel room door, it'll say list price of this room, some enormous amount, $500 per night or something. You're like, I paid like $120. Didn't I get a good deal? That's not accidental, by the way. All right? So there is some list price, which is owned by one service. And then you can think of this as a set of transformations, where the service that owns the dates, for example, the black service over there, said it's the one that knows the dates. It can be aware of what is high season and what is low season. So based on the dates that are coming in, it can say, oh, this is high season. We need to perform a multiple. This is going to be multiplied by 1.2. Or this is the low season. We're going to multiply the list price by 0.8. So in essence, it's performing a kind of transform on the data that came in from the previous step. And then there is the service that deals with the, well, how many people are going to be part of this reservation? It says, oh, there's a large number of people. We're going to decrement that by a 0.7. Or this is a small number of people. We're going to leave it as just a factor of 1. And then there's going to be some other service that deals with some other elements, and it's going to perform some other transformation. All right? So each service here, in essence, is providing a NuGet package that is deployed alongside this generic price processing pipeline. And it doesn't really need to know who came before it, who comes after it. Each of them gets invoked. There's usually going to be a common identifier, like the booking ID that we mentioned before, that is going to be flowing through all of this as well. And then this service says, okay, let's get the dates, and this one says, let's go get the whatever, and this gets the, some other factor. So each service operating on its own data is creating some kind of transform of the input that it received. And the engine needs to be structured in such a way that it doesn't really matter which order we're doing the transformation. So whether it's first times 1.2 and then times 0.7, or first 0.7 and then 1.2, the end result ends up being the same. All right? And that's how we're able to preserve the independence of each of these services, each of them operating on their own data. And the end result sort of coming out and saying, oh, okay, so the final price that was quoted to the user was X. Okay? Same thing if we're talking about a fraud score, where we get some order coming in and something is saying, well, let's check out the IP address, and something else is saying, let's check out the shipping address, and something else is saying, let's look at the order total. And each of those things is providing some kind of score to say this increases the risk by this percentage, that decreases the risk by that percentage. The thing is, and I mentioned this with regards to team structure, usually this is going to require a team of its own, where you're going to have, in essence, a person on that team who is also a member of a service team. So they're kind of wearing two hats. This is the person in the sales service team that is in the pricing engine team. So you need someone who can wear both hats to know enough about a specific service domain and enough about the engine domain that they're in. This group of people tend to have to work with each other fairly intensively. And the person for each of these services tends to be more of a liaison back to the rest of the service team. So there tends to be quite a lot of tweaking and optimizing that happens within this group. So they tend to work with each other much more frequently with some data science-y type stuff as well, much more so than the person here would be working with the rest of the blue service. Okay? And this is one of the reasons why organizations that have operated with the team per service model that have started to feel some of the strain, because they need more complex rules around pricing. They need more complex rules around risk scoring. And then they end up creating these types of engines, because really that's the only way to preserve service boundaries while at the same time composing them together. And then that puts a strain on team structure. Howard?
Yeah, you call this the engine pattern, because is that sort of a generalization, and then you would call sort of rule engine a more specific pattern within the same thing in a way?
Right. So there was a time that rule engines were all the rage. Now,
all of this fits very neatly, especially when you say score and stuff like that. Fraud and risk and everything just matches
right.
very well.
Now, the issue with rule engines is that, and this was kind of I'm not sure I'd say their downfall, but it definitely contributed to some of the problems with them, is that there wasn't the understanding that actually the rules that are being run in the rule engine are not owned wholly by the engine. In other words, this is not a monolithic set of rules, but that some of these belong to service A, and some of these belong to service B, and that there's data that these rules touch that those rules shouldn't touch. And as a result of that, a lot of rule engine implementations became the next wave of EAI broker failures, because they just tried to handle too much and access all the data in all the rules in one monolithic sense, and then it crumbled under its own weight. So rule engine, there's nothing about rule engine technology that forces you to have all of the rules be owned by the rule engine. You can partition them up and group them and name them, and to have your own type of constraints to say, these rules can only touch this data and not that data. And that will influence the way that we write the rules. The problem is that that required discipline. And some of the promise that was made around rules engines is that non-technical people will be able to write the rules. And non-technical people, without necessarily the affiliation or the understanding of why it's important to have boundaries and discipline and what can access what, that percolated and caused those problems. So as long as we're preserving that element of who owns what, that there's the generic ITOPSy type of engine together with the services that are plugging into that, then rules engines very much do fit that same pattern.